This video is going to cover the chain rule, which is the last of our derivative rules. It's also the most complicated, and it's going to give us the most complicated problems to do, unfortunately. Also, it's an incredibly commonly used problem. In fact, from here on out, you are rarely going to have a derivative that won't use the chain rule as part of it. So you really need to learn this one well. And this chain rule applies whenever you have one function inside another function. So, for example, let's find the derivative of f of x is sine of x cubed. So you see you have the x cubed function inside of the sine function. And so whenever that's the case, we have to use the chain rule. And the chain rule says you need to think of the outside function and the inside function. So in this case here, the outside function is the sine function and the inside is the x cubed function. And what it says is you take the derivative of the outside function, but you leave the inside function inside of it, and then you multiply by the derivative of the inside function. So the outside function is sine, and the derivative of sine is cosine. Now it's not going to be cosine x here. The reason why it's not cosine x is because it wasn't sine x, but it's cosine of whatever thing you already had, which in this case was x cubed. Then you multiply by the derivative of what's inside, which is 3x squared is the derivative of x cubed, and this would be your answer. Now, it probably looks nicer, and usually the back of the book would put the 3x squared first on it. So it looks something like this, but that's what we have. Similarly, if I want to take the derivative of e to the negative x squared, well, the outer function is e to something, and the inner function is a negative x squared. So the derivative of e to something is e to the same thing times the derivative of what's inside, which would be negative 2x. And again, we usually prefer this as negative 2x e to the x negative x squared. Or I could say take the derivative of, let's say, e to the x squared plus 1 tangent of square root of x. And you see here we have two different functions multiplied, and so we're going to start with the product rule. So we're going to say the derivative of the e to the x squared plus 1 first times the tangent of square root of x plus the first e to the x squared plus 1 times the derivative of the second tangent root x. And then for each of those derivatives, it's a function inside another function, so we're going to need to use the chain rule here. So the derivative of e to something is e to the same thing times the derivative of what's inside, 2x. And don't forget, we still had this tangent square root of x there to deal with. Then we're going to have plus, and we have e to the x squared plus 1. And then over there we're going to have the derivative of tangent of square root of x. So that's tangent of something. Tangent of something goes to secant squared of the same thing times the derivative of what's inside. And we saw way back in the previous video the derivative of square root of x is x to the 1/2, so it's going to be 1/2 x to the negative 1/2. And again, I would not recommend trying to simplify this. I mean, maybe you could factor out the e to the x squared plus 1, but other than that, I would just leave it at that point. So you see, at this point in time, we can kind of combine quotient rule, product rule, chain rule all over the place here. It could be as simple as trying to find the derivative of sine of 7x. So the derivative of sine something is cosine of the same thing times the derivative of what's inside, 7. So So we'd have 7 cosine of 7x. But it also could be much more complicated. And in fact, you can have problems where you're going to use chain rule multiple times. So let me give you about as bad as it could possibly get here. We're going to find the derivative of the square root of e to the cosine of x tangent x. Alright, so I guess I don't need this as long here. So you see we have all sorts of things inside of each other. So the most outside function is square root of something. And we know that the square root of something goes to 1/2. Then it's going to be the same something to the negative 1/2. Then we're going to multiply by the derivative of the inside part. That's the first chain rule. Then we're going to take the derivative of the inside part. The outside function of that is e to something. And e to something goes to e to the same thing times the derivative of what's inside. And then the derivative of what's inside there is cosine of something. Cosine of something is going to go to negative sine of the same thing times the derivative of what's inside. I'm running out of room here. So the derivative of what's inside, finally, instead of chain rule, we're going to need product rule there. And the derivative of the first is the derivative of x is 1 times the second plus the first x times the derivative of the second is secant squared. And this whole mess is going to be the derivative. And again, I would not recommend trying to simplify that. It's going to be a mess no matter what you do. It's not worth spending an hour doing algebra on it and hoping that it'll work out nicer. But that's what we have here. So the chain rule, it's the big deal. I gave you a lot of homework in this section. You really want to practice it over and over and over again. And this is, what we need.